first image from the world's largest solar telescope captures the Sun in unheard-of detail. A newly released image of the Sun captured by the world's largest solar telescope shows the surface of our nearest star in unprecedented detail, shedding light on its fiery complexity. The image is the first taken by the U.S. National Science Foundation Daniel K. Inouye Solar Telescope's new Visible Tunable Filter, or VTF. The instrument can build a closer-than-ever, three-dimensional view of what's happening on the Sun's surface, according to a news release. The close-up reveals a cluster of continent-sized dark sunspots near the center of the Sun's inner atmosphere at a scale of 6.2 miles 10 kilometers per pixel. These blemishes mark areas of intense magnetic activity, where solar flares and coronal mass ejections, or CMEs, are likely to occur. Coronal mass ejections are large clouds of ionized gas called plasma and magnetic fields that erupt from the Sun's outer atmosphere. Detailed images such as this one, which was taken in early December, pose an important way for scientists to learn about and predict potentially dangerous solar weather, said Friedrich Woger, the NSF Inouye Solar Telescope Instrument Program scientist, in an email. A solar storm in the 1800s, the Carrington event, reportedly was so energetic that it caused fires in telegraph stations, Woger said. We need to understand the physical drivers of these phenomena and how they can affect our technology and ultimately our lives. These energetic outbursts from the Sun can interact with our planet's own electromagnetic field, causing disturbances to key infrastructure such as electrical power, grids, and satellite-powered communication networks, he explained. The Sun goes through periods of high and low magnetic activity in an 11-year cycle. In October, scientists from the National Oceanic and Atmospheric Administration, NASA, and the International Solar Cycle Prediction Panel announced the Sun reached the peak of activity, called the solar maximum. During the peak, the Sun's magnetic poles flip and more sunspots appear on its surface. The maximum is expected to last for several months, so it's a fitting time for the Inouye Solar Telescope to be ramping up its instrument testing with spectacular images of the Sun's dynamic surface. A closer look at the Sun like boiling soup on a stove. Heat escapes the core of the Sun and rises to its surface through fluid motions, said Mark Misch, a research scientist at the Cooperative Institute for Research in Environmental Sciences at the University of Colorado Boulder. Misch was not involved in the research. Sunspots, then, are like magnetic plugs, or tangles in the star's complex magnetic fields that prevent the heat from reaching the surface. Misch said, for this reason, the sunspots, which emit less light than other areas of the Sun, appear darker in images and are cooler than their surroundings. Nevertheless, sunspots are still hotter than any oven on Earth, he added. The apparent texture of the Sun comes from the varying densities and temperatures within its surface, which has layers similar to an onion. By tuning into different wavelengths or colors, like a radio tuner, the VTF offers a way to probe these various layers and observe what is happening between them. Misch said, in other words, while an image from a personal camera uses light that contains multiple wavelengths at the same time, the VTF, a type of imaging spectropolarimeter, filters measurable wavelengths one by one. To accomplish this filtering, the instrument uses an etalon to glass plates separated by mere microns. The principle is not unlike that of noise-canceling headphones. When two waves with similar wavelengths travel on the same or an intersecting path, they can interact with each other to either cancel each other out or they can reinforce each other, Woger said. Light waves trapped between those two plates interfere, and the distance between the plates selects which exact colors of the light are passed on and which ones cancel out. In just a few seconds, the powerful instrument captures hundreds of images through the different filters and combines them into a three-dimensional snapshot. Researchers can then use the resulting views to study the temperature, pressure, velocity, and magnetic field structure at the errant layers of the solar atmosphere. Seeing those first spectral scans was a surreal moment. This is something no other instrument in the telescope can achieve in the same way, said Dr. Stacy Suoka, a senior optical engineer at the National Solar Observatory, in a statement. What's next on the horizon? The imaging spectropolarimeter represents a culmination of over a decade's worth of development. Located at the NSF's National Solar Observatory, at the top of Maui's 10,000-foot 3.0-meter heliacal volcanic mountain, the VTF itself spans multiple stories of the Inouye Solar Telescope. After the VTF was designed and built by the Institute for Solar Physics in Germany, the instrument's parts were shipped across the Atlantic and Pacific Oceans, and then reassembled like a ship in a bottle, Wolger said. The team expects the tool to be fully operational and ready for use by 2026. The significance of the technological achievement is such that one could easily argue the VTF is the Inouye Solar Telescope's heart, and it is finally beating at its forever place, said Dr. Matthias Schubert, a VTF project scientist at the Institute for Solar Physics, in a statement. The Solar Telescope is among several other recent efforts by scientists to better understand the Sun and its stormy weather patterns, including the Solar Orbiter, a joint mission of the European Space Agency and NASA launched in 2020, and NASA's Parker Solar Probe, the first spacecraft to touch the Sun.